Mathline, you're at the right place, right time. Hey, anytime is a good time for Mathline, isn't it? I tell you what. This is Specialized Segments Day. I am your host, Ernie Roberts, and I am glad you've tuned in with us, no matter whether you're online with us or whether you are watching us by streaming, or perhaps you're even watching us live on TV, but whatever. We are so glad you're with us, all right? And it's not a call-in day, so keep those back. In fact, we're getting kind of into those nice summer school type training sessions and what have you. And we're going to be looking at some topics, as we call them, specialized segments today, and going in depth and working and doing some examples. So what you need to do, oh yes, what you need to do, first relax, sit back, get your calculator, get your pencil, get your paper. We're going to have some fun. Let's do some math, and let's see what we're going to do math with today. Keeping up with the proportions. The proportions. Yeah, it is the proportions, exactly. Round two. That means there was a round one, and hopefully you look back at it. If you didn't get a chance to see it on TV or on the internet, it's out there, all right? So you can check it out and have fun with it. But let's go to round two, and we'll give you a little bit of an update to get you up to speed from round one. Let's solve for x in the proportions below here. And again, just a quick review. What's going on in these problems? Well, we've got little values of x that we'd like to know what it's equal to. And some of you are going like, well, Ernie, those numbers all kind of look about the same, but you've got them sprinkled around in a different location each time. Absolutely, because notice here, x hung out there in that slot, and then x moved here, and the 10's bouncing around. Oh my goodness, it's all over the place. So why did we do all those three proportions when they look sort of like they could be the same? Let's find out they are, okay, if they're going to give us the same value, all right, and see where we go. Looking at, first of all, let's go back to some terminology here. You're going to hear me use it occasionally once and out in here. And if you're in a geometry class, you'll hear it from time to time also. There are things called the extremes and the means in a proportion problem. These, I like to call positions 1 and 4 here. Those are your extremes. They're going to join together by multiplication, which is going to give us a nice little 4x on there. You see that? And the means, well, we're going to do the same thing out through here. We are going to multiply. And sometimes we call that a cross multiply. Look like it's a big old mess there. It looks like a big X, right? That's what goes on there. But that only works if there's an equals between there, by the way. So let's see what happens. What does 4 times x look like? It looks like 4x. Now, sometimes I have viewers who call in and say, I don't understand what those 4x things, they always bother me when they start putting letters and variables and stuff. That's the fun part, because it means we don't know what it is yet, right? But it's 4 times something. It's 4 times some number, some value that is going to allow us to get what on the other side? 7 times 10. Now, that we don't really have to go to calculator, do we? That's always kind of nice, isn't it? We can do something in our head. And this one is definitely a do it in your head moment. It's going to be give us 70, and we have 4x over here. Now, I know some of you are saying like, Ernie, I think I can divide that out in my head. I don't know if I want to divide it out in my head. So let's go to the calculator on this one. How about it? Let's see what 70 divided by 4 will give us. And yeah, you can do it with your paper and pencil there, but calculator is just as much fun, if not even more fun. And it comes out fairly nice, but it is a little bit bigger number than what we may have been expecting. 17.5, all right? So our x value there is 17.5. Now, if we look here, my question is, are we still going to get 17.5 for this one and this one? And is that always going to happen no matter what we do with the numbers, all right? Big question mark here. So let's go back to our little moment here. We're going to extremes, you got it, put them together, multiply them. We're going to do the means, put them together, multiply them, and let's do that right down below here. Those of you who didn't follow me the last time, hopefully you're following me this time. You got 4x. Going this way, we have again, that's 7 times 10 again, isn't it? Well, we know that's 70. We'll put it right there. And you know what? Got the same thing here as we got there. It's got to give us what? 17.5. Absolutely. So here we go. 17. Some of you like that 0.5, I know, or 5/10. And wow, that was pretty easy, wasn't it? Well, what was the difference here? What was the difference between here and here? Because we wound up doing the same multiplication. Really what happened was we just interchanged the means. Life was good. All right, life was good there. Now, what is happening here? Ooh, it looks like we've now decided we're going to let the means become the extremes and the extremes become the means. Well, that's kind of almost like confusing, isn't it? We just basically switched a lot of directions, but we really did look at what went on from here to here. We interchanged numerator and denominator. That's where we got 7 over x. And as long as we keep going in the same direction, in other words, we had x over 7 equaling 10 over 4 here. Since we switched the left side, interchanging numerator and denominator, needed the same thing over here. And that's what we did. We changed our 10 over 4 to become 4 over 10. Don't let that sound complicated. It just simply says, if you do something to the left, fix it, change it, you've got to change the exact same method, exact same way on the right, okay? Otherwise, you're going to have a mess. And it's not going to be a proportion anymore. It's going to be a mession, all right? So let's see where we're going to go. Cross multiply. Why, yeah, everybody's saying, Ernie, get 4x. And on the right, oh, yeah, we're going to have 7 times 10 again. I didn't have to draw the arrows, but you know, I will just to make sure everybody's good on it. See how that 4 and the x connect? 7 and the 10 connect. And we got, what, my goodness, we got 70 again, don't we? And x would equal 17 and a half. Now, I think there's some of you out there, I probably think there are. I don't just think, I know there are. Some of you are asking me, well, could you have reduced 10 over 4 and made it a little bit easier? I certainly could. I had 5 over 2. I'd still cross multiply and get 35 this time and 2x. See what I'm saying? If I made this become, let's say, put a 5 over 2. Let's see if I can make that work. There we go. I don't want to make it too large there. But see what's going to happen? You're going to divide 2 into 35. And guess what? You get 17 and a half. That's the beauty about proportions. Now, can I do a moment if I had a 4 and a 10 going here on my, where I'm going to multiply together? No, you cannot. You cannot cancel in that manner, okay? If there was multiplication, yes. But this is an equal staring us in the middle where it was until I put x's there, didn't it? But don't be tempted, all right? But you can reduce in the vertical fashion. You could make this 2 over 5 also and get where you're going. Now I said, what would happen if we did decide not to follow suit here? In other words, let's say I changed that 7 over x and forgot. We ever do that? And left 10 over 4 going here. I'm going to tell you, it's going to be a different story, isn't it? Because you're cross multiplying. There you go. There's your extremes working. There's your means working. So you got 10x equaling to 28. I guarantee you are not going to get 17 and a half. Nowhere close. Divide that, you're going to have x equals 2 and 8 tenths. Okay? Or if you like the fractions, that would be 2 and 2/5. Obviously, nowhere close to 17 and 1/2. All right? So again, fractions or decimals, they're fine. I will give you a hint. Generally, rule of thumb we like to do with proportions, if they come out even, decimals are cool. If they come out even, fractions are even better, you know. But when they don't come out even, they ramble on and on and on. It's nice to write that as a fraction, a mixed number, if you will. So, you know, if they've been 6, 6, 6, 6, 6, 6, 6, 6, keep on going, that becomes 2/3, all right? So 2/3 you would want to write rather than 6/10 or something like that, okay? Yeah, you always want to be careful when you're writing these things. So take your, you know how to do fractions, right? Everybody does, right? So just, either way is fine as long as they come out even, but be careful when you get some of those rambling on situations that don't stop. Some of them are repeating decimals, some of them are just rambling, okay? So be careful on those. But let's do some proportion solving. That's what you came for, right, today? We want to keep up with the proportions. Now, you know how the best way to keep up with it is keep the pattern identical left side, right side, all right? Or did I say left side, right side? I never know what y'all are looking at with me on the backward side of the TV. But let's have some fun with these things, all right? Lisette is on a trip, my goodness, driving 360 miles in 5 hours. That's pretty good pace, young lady. At that rate, how much longer will it take her to drive an additional 90 miles? Ooh, okay. So, key word, at that rate, actually 3 words, isn't it? That's important because we want to keep the ratio, the rate at the same. So let's map this thing out. You said, map it out, Ernie? What do you mean? Let's set it up because that's what is the hardest thing about word problems. So many times we wonder, figure, what are we going to do? How are we going to set them up? So let's look at it. let's talk about this time. It looks like we're going to do distance and time. Same thing here. How far, how long, distance, time. Oh yeah, we could put miles over hours. Sounds good. That's distance. That's the time, isn't it? And miles over hours. Notice what I'm just saying here. Keep the pattern flowing the same, because we want these ratios to the left to equal the ratio on the right. Make sense? Everybody nod your head with me? Of course it makes sense. Absolutely. So let's see where we're going on this. We have 360, and we're going to divide that by how much? What do you think? I think y'all got it. I think y'all got where we're going. 5 hours, right? That'll come out even because 5 divides in with a 0. Notice that. That'll be good news because that's a good rate and a good ratio for us to work with. Now, the question is, how much longer will it take for her to drive an additional 90 miles? Now, some of you are thinking, Ernie, do I need to add 90 to 360? You can do that. It means you're going to have to figure out something a little bit more in the end. Why don't we just say the rate's the same? Let's go with 90 and see what is our time. We'll call it a T right there. This could look interesting. Already, I think it's looking interesting. Let's see what happens. See what we end up with here. How much time is it going to take? May not come out just to 1 hour or 3 hours or 4 hours or whatever. Let's see where we're going. Cross multiplying, you got it. This time, we got a big number. That's why we have a calculator with you. That's why I told you, yeah, have those calculators ready. And here we go, 90 times 5. And I'm going to write those numbers with you because I want you to realize that we are picking up those two means to multiply. And here we got 360 times this value of t. How much time is it? And that is a 60, by the way, there. Sometimes if I get my little pens get a little blurry up here. What is 90 times 5? Yeah, this is a good question here, right? How about 450? Over here we got 360 times the time. Let's divide, unwind this craziness, and let's see if we can clear out. And let's go to our calculator. This is a little bit not so pretty. So we got, 450 divided by 360. And some of you say, Ernie, I think we could have reduced that like a fraction or something. We could play with them. That's what I love about numbers. There are a lot of things you know, woo, that looks really good. So our time is 1 1/4 hours. Those of you like to figure out what 1/4 of an hour is, I hope you do. That's an hour and what? 15 minutes. Because how many? Yeah, that's 60. What's 1/4 of 60? It'd be 15 minutes, all right? So there's one way to look at it. Remember I said one way to look at it. That's just definitely the increase. Now, if some of you decided to do this, what if you had said 360, am I going to have room? I think I will. Over the 5, go back to that rate. By the way, what are we driving here? It looks like we're driving 72, what? Yeah, 72 miles per hour is what it looks like, okay? You figured that out? I think you probably have. Let's put 540 this time. And we'll put our time there. Now, what we just did here, you say, well, Ernie, you're going to get a different T. We are, but we're going to have to think in answer to the question, okay? And a lot of times we forget to go back. When we set a variable in, sometimes we forget. This was absolutely perfect because we made it with the 90. It worked great, okay? Now, let's cross multiply this time. Ooh, this one looks a little bit crazier. How about it? 450 times 5. And we get, 2,250. And we got this 360t coming at us again. And now we're going to draw a little line here. Let's divide by 360, both sides. And you're saying, Ernie, that's not going to give us 1 1/4. Absolutely not. It won't. But we're going to be able to get 1 1/4 from that answer. Just trust me, all right? Let's see. We've got 2,250. We'll get it right in a minute here. Did I punch it in right? I did it right. It was already there. I could have just gone straight to it. Let's divide that craziness by 360. If you notice with proportions, you basically multiply and you divide, and then you see what do you have to do with the leftover mess, okay? And sometimes it's a mess, sometimes it's not so bad. So here we go. 6 and 2,500. Where did we start? We started 5 hours. how much more did we go? The gain, the increase, time is still 1 1/4 hours. Okay? So, yes, more than one way to work that problem. And someone's already thinking, could we put distance over distance? Yes, we could, as long as we make sure the time is the correct one with each distance as we match them up, okay? A cross multiplication, we would still get the same ending up with 1 1/4 here. If we played the same game over here, we would still end up with 6 1/4, which we know takes us where we want to go. So good problem there, Lisette. Happy driving to you. And I hope, once again, that some of you are seeing, oh, it doesn't always have to be just one set way to work it out. But I do like those rates versus the change of the rate of change going on there, okay? And you keep that going, it's usually pretty easy to keep it straight. Speaking of which, let's take a look at another type of rate, the exchange rate. Now, folks, you know as well as I do, these rates change and fluctuate throughout. So I don't know when you're going to see this. I don't know when this actual problem was set up, that the rate was at 11.2 pesos per dollar, all right? But that's what we've got here. We've got this ratio. We're going to work with it, all right? And this vacation, when this was the rate, Ed was down in Mexico, and he paid 150 pesos at a gift shop. We want to know, and it's really true, we do like to know, how much is that in our U.S. dollars if we're from America? If we're other countries, we want to know what it is in the rate of our currency also. What's in the rate of the euro? How does it compare? How does it compare to this? How does it compare to that? So let's see how we're going to work this. We're going to take that rate, which we've got there, 11, that's 2/10, all right? Basically, it's 11 1/5 of a peso, all right? But those tenths add up, and those fifths add up, and all sorts of good things. Now, this was, what was this? This was peso versus dollar. Guess what? We've set up the pattern. Stay with it. Stay with it. Still keep the peso and the dollar. We don't know how much dollars. That's what's interesting us, all right? But how many pesos did we get? I'm going to put it in there. It's 150, right? So we'll put a 150 in that numerator. So let's lose the pesos and the dollars here, and let's just look at it as a nice proportion. There we have it. 11 2/10 over 1 equals 150 over X. Now, as I've said before, we could do peso to peso, but then we may make dollar to dollar, all right? Just keep that in mind. Keep that in mind. Set the pattern, stay with it. You will not lose your sight in getting to the final answer. Speaking of the pattern here, it's not as pretty as some of the other things we've done, but you know what? Money is not always pretty, all right? So let's see what happens. Let's cross multiply and see where we go. Hit those extremes. We're going to have 11 2/10 times our X. Hit those mean 150. That was easy. You know what we got to do here? And you're going like, Ernie, that's not pretty division. Absolutely not. But we're going to divide by 11 2/10, both sides. Clean it up. Say goodbye to those. Now do a division. Hit the calculator by all means. It looks like it's going to at least be over $10 he's spending here. Let's see what we've got. 150. We'll see if I can get it there to work. 150. And we're going to divide by that 11 2/10. It's crazy looking at it, folks. I'm going to go with that amount of money is going to be $13, and we'll go 39 cents on it. We'll round it as it says. All right, we'll lose the 285714. We'll lose that and stick with this being our value. That's where we're going, all right? And again, that rate's constantly changing. It changes day to day. It changes, I mean, things get devalued here, they get raised up here, inflation strikes, all sorts of things. So the process is still the same. Pesos per dollar, pesos per dollar. And you'll be able to figure out where it's going. So you said, it's just like dividing, isn't it? Absolutely. It's like dividing, because if we were to write peso over peso, we would be doing a division thing, all right? And that would give us the amount of dollars. So there you go. It's, like I said, it's all about multiplication and division. And in this case, it winds up being just a pure division situation, right? Because it's easy to multiply 1 times 150. Then divide what results are left over. How easy is that? It's easy. It's just setting it up, right? And if you keep the pattern going, it works great. Let's do a scale problem, another scale drawing problem. All right, here we go. A model of an Army tank has, wow, 1 to 12, has scale of 1 to 12 of the real deal. The height of the tank is actually 9 feet. How tall is the model? All right, now here we go again. I don't think this model is probably going to be read out in feet. All right, so let's do a little job here. Let's get a ratio. Remember, we like to write. What's the problem? What's the storyline here? So this scale, what is this talking about? This is the model versus the real deal. All right, so we'll put model and we'll call it real. Okay, the height of this tank is actually 9 feet. So again, that's the real deal. And we're looking for what's the model size. So let's get our ratio in there. 1 to 12, since they gave it to us in that way. By the way, we think of it model to the real deal, okay? On the other side here, what's going on? Well, we got, what do we have? We got 9 feet. For where? The real deal? Let's make that into some real, how about it? We'll go with 96. You good for that? Or we go to 9 feet? Let's go 9 feet. We'll change it in a minute. And the model? We'll put an M there for model. We don't know what it's going to be. But it looks to me like, y'all look, see what I'm noticing here? I am seeing, when we cross multiply, we're going to 12 times the model, that works, equaling 9. Now, some of you go like, well, Ernie, what do we do now? We do what we've been doing all along. We divide both sides by what? By 12. So put that through there, and we get a fraction. That's okay. We can handle fractions. Why don't we reduce that while we're at it? Because that's going to give us 3/4. You say, what's 3/4, Ernie? 3/4 of a what? Of a foot. Because that's what we have going on here. This was 9 feet, so we're talking this as feet. And guess what? That's going to give us 9 inches. Another way we could have done this was transform that feet to inches. That'd be 9 times 12. And you know what? Because we got a 12 here, it really worked out pretty nice. All right. Does it always come out that way? Only if you have the 1 to 12 ratio. If that had been 1 to 18 or 1 to 25 or something like that, it'd been a much bigger deal. All right. Much different. But we got 9 inches, and you could have worked it out also by changing this to inches to begin with and cross multiplying. But we can handle it. And by the way, don't get nervous if this number next to the variable is larger than this one over here. Make a fraction, reduce it, and you'll say, oh, that's not so bad. It's 3/4. It's like 3/4, right? So that's your story. I'm sticking to it. You all will too, all right? Let's see if we get one more in here. Got a little shadow problem coming our way here. And let's talk about a person who's 6 feet tall casting a shadow that's a little bit longer. And notice I'm going to draw a picture here. Actually, we'll give her a little more height, or him. It doesn't matter, right? 6 feet. Here we go. And down here is 8 feet. Over here, same light conditions. We've got a 5-foot person who's a little bit shorter, who also, by all means, will cast a little bit shorter shadow. Does that make sense there in proportion? How do we know that? Well, this is a right angle here. Usually we think of them standing up pretty straight. And we'll draw in. We could draw in a little bit more here. You say, Wernie, what's that about? That's kind of where your shadow's falling, isn't it? From the top of her head down to the ground there. And now we're going to do the same thing here. Folks, the deal is these triangles are similar. These triangles are similar, which means their sides are in proportion. Now, how tall is this? Our person over here is 5. And we are trying to figure out how much less shadow. Oh, my goodness. Well, let's go for it here. We'll find out the shadow. We'll subtract it, right? So put an X right there. Set it up. How about it? 6 to 8. I like that. We'll take it. Height to shadow equals height to shadow. Cross multiplying. Let's see where it goes. We have 6x equaling to 40. Let's do some quick division. I think that's going to give us 6 2/3. All right? So this is a 6 2/3 foot shadow. But guess what? The question asks for what? How much less shadow will that person cast? So subtract. So do a quick subtraction on here. 8 minus 6 and 2/3, which is going to leave us with 1 1/3 foot. If you like to take that to feet and inches, it's 1 foot and what? 4 inches. And that would be the difference. That would be how much less shadow. Now, someone's going to ask, could we have done 6 minus 5 and played the same game? I'll let you figure that one out. That one's a little bit tougher to answer because we really don't know what the change is here, do we? So we have to go here, then subtract it, and that, folks, is how you keep up with the proportions and the proportions. Hey, it's been great to have you with us today. Thank you for tuning in. We will be back again throughout the summer and see you again next time.
It's the 30th anniversary of an American tradition, the National Memorial Day Concert.
Join me, Joe Mantegna.
And me, Gary Sinise.
With Sam Elliott, Patti LaBelle, Alison Krauss, Dennis Haysbert. The National Memorial Day Concert.
Come and explore Knoxville's first home. Founded by a Revolutionary War captain, James White's Fort offers an inside look at an 18th century American settlement. Tours, classes, private events, living history, and more. Come and unlock Knoxville's past. For more information, jameswhitesfort.org.
Growing up in the 80s, we used to play hide and go seek, hopscotch. All of a sudden, those streets I used to play in were flooded with violence and drugs. I looked out my window where my neighbor had been shot, and I really didn't see myself making it to 21. I retreated to my living room to find safety. PBS became a window into a broader world. If I ran home, I got to watch Bob Ross. It would just soothe me. Art is an extremely important part of my life today. I'm one of the founding members of Artists for Humanity. I do my best to keep kids out of gangs, to make sure that there is a clear path towards success. I found that path through PBS. Growing up, sometimes I felt despair, but when you can turn on the television and see a beautiful world, it gives you hope that you can make it to that world.
Black Violin, Thursday, May 30th at 8:30 p.m. Exclusive member tickets available.
Direct from a sold-out run in New York City, The Lightning Thief, the Percy Jackson musical. The New York Times bestseller is now live on stage. The Lightning Thief, the Percy Jackson musical.
Tickets available at ClaytonArtsCenter.com.